Easy breezy, all right? This one, that's the new skill, Algebra 2 skill. Never done it before, okay? We'll get to it towards the end of class.
Yay.
So let's do this guy first, all right? So example 1. Now y'all listen to me. I'm going to work one problem with you, and I'm going to try to show you a bunch of stuff. Everything that I show you, I have already taught you. If you don't know how to do it, shame on you, okay? Because you just worked a partner test, all right, where you should have done it each one. Now, this was one of the cool things that happened in one of my other classes. In one of my other classes, I have a really good math student who partnered with a person that could be a really good math student but doesn't particularly do all their work. You know what I'm talking about? Okay, I hate this on YouTube, but anyway, they'll probably never watch it, but anyway. Anyway, so the person that was a really good math student made that other person do all the work on that partner test. And then he watched to make sure that he did it all right. Okay? That was a good friend. Because what happened to that guy that hadn't been doing all his work and taking care of all his business? He learned. He got really good at it. He was like, wow, I really know how to do this stuff. And he goes, he wouldn't do one problem. I had to do everything. And he just watched over it. And I know he watched over it and made a really good grade on the paper. Okay? So that's what it's about. Guys, listen to me. You don't help somebody when you let them copy your homework. That's not a good friend. Okay? Not a good friend. So here's the first problem. Graph. Y is greater than, inequality means no equal sign, we're going to have greater than and less than signs. Y is greater than x squared plus 3x minus 4. Okay? So I know I'm going to graph this on a coordinate plane. So I'm going to just go ahead and draw mine. Okay, so there's my coordinate plane. In order to graph this, I can do a lot of things, okay? I could do that h is equal to negative b over 2a, right? And find the h coordinate of the vertex, and then plug it in and find k. I could complete the square. Do you agree with that? What makes me not want to complete the square?
It's a perfect, but
Look at this guy right here. What are you going to be doing to him? Taking half of him? So most of the kids are going to be like, nah, I'm not going to do that because there's a fraction right there. So they're going to shy away from that. I'll do it later on, but I'm going to show you how I would probably do it, okay? So I'll look at this and I go, can I factor that pretty easy? You agree you can factor it? 15 seconds, you factor it. Go. Okay, you got it? Now listen to me. If you couldn't factor that in that long, that means you're behind. Okay? Is it going to cost you later on? It's going to keep on costing you. The rest of your mathematical career, whatever that might be, the rest of high school and whatever, if you have to take one class, everybody has to take at least one math class in college. Okay? So learn how to factor. What does x squared factor into?
x plus.
What does a minus sign at the end mean? Yeah, plus and minus. The factors of 4 are 1 and 4 and 2 and 2. Who subtracts? This is my cheater sign. Y'all, this is an easy one because it's got a 1 right there. Okay, if it's anything other than a 1, you can't do this. Cheater sign. Who subtracts to be 3? 1 and 4. I want a positive 3, so who goes by the plus sign?
4.
And then 1 goes by the negative. If you wanted to check it, you could go, that's a positive 4x for the inners, and the outers give you a negative 1x, and there's my positive 3x. Everybody okay? All right. So if x plus 4 is the factor, what's the root? Yes, negative 4. Very good. If x minus 1 is the factor, what's the root? 1. So what are these with respect to my graph? They're my x-intercepts. 1, 2, 3, 4, and positive 1. All right, now I'm feeling pretty good. How does this parabola open? Up. He has a positive x squared. Is he wider, narrower, or the same as the parent function? The same. Are you with me? Think about all that stuff? Okay, so I need to find his vertex. I got 2 points, but I have to know the vertex. Where is the vertex located with respect to these 2 points? He's in the middle. Do you agree? Down here somewhere, obviously, because he's opening up. All right? But his x-coordinate is in between these, right in the middle of these. He's the midpoint of these 2 numbers. Do you understand? So the vertex of this is called h. So he's equal to, how do I find the midpoint between these 2 guys? Yeah, don't subtract them, okay? Because listen to me, if you subtracted these, you would get -5, okay, and divide by 2. No, you gotta add them, all right? -4 plus 1 divided by 2. All right, so what's -4 plus 1? -3/2. So my vertex, the h coordinate or the x is -3/2. Now how do I find the y? Yeah, people plug it in. Plug it in. People, that's an 8th grade skill. Come on, we got to know how to graph. Okay? So you take this is h, he's x. For what's my y? It's just like a t-chart. Take this guy and plug him in up there. Are you with me? So k, which is the y coordinate, all right, is equal to, I'm right here, x is -3/2 squared plus 3 times -3/2 minus 4. All right, what do I do first? Square? When you square a negative, what will it always be? Okay, what's 3 squared? 2 squared? Perfect. What's a positive times a negative? Put this guy over 1. How do you multiply fractions? Top times top, bottom times bottom. Nothing cross cancels, guys, okay? So you're just stuck. So 3 times 3 is 9. 1 times 2 is 2. And then minus 4. I'm going to go ahead and put him over a 1 because don't you agree I have to find a common denominator? Are y'all with me? Okay, so what is my common denominator? Y'all listen to me. This is something that I see kids do all the time. Y'all, if it's a common denominator, then make it common. Put it under everybody. Okay? Don't go 4, 4, 4. They get a common denominator. Okay? Only write it one time. What's a common denominator between 4, 2, and 1? 4. This guy, he's already over a 4. So if it ain't broke, don't fix it. So we write our 9 down. All right? What are you going to do to this guy? Times 2, so you multiply the top times 2. Okay? What is -9 times 2? All right? What are you going to do to this guy? Times 4, so times 4. What's -4 times 4? All right? So I'm going to say 9, -18 and -16 is -34. And then 9 minus 34, -25. So -25 fourths. Are you with me? Okay. So let's graph that really quick, and then I'm going to show you something. Let's change these into mixed numbers. How many times does 2 go into 3? With how many left over? So that's -1 1/2. All right? You see what I'm doing? Because my brain sees that. I say 2 goes into 3 one time with 1 left over. All right? Because this is, my brain's, he can think this, but when I go -25 fourths, my brain doesn't go, oh, I know exactly where that is. Okay? So we rewrite it as a mixed number. How many times does 4 go into 25?
6.
With how many left over? So my vertex is -1 1/2 down -1, 2, 3, 4, 5, 6 1/4. So he's right here. Okay? Now before I graph it, because last period I just slapped it on there really fast, I need to look back and see, is it dotted or solid? Yeah. He doesn't have an or equal to on him, so he's dotted. Now there's lots of times when you just graph him and then you go back and go, oh dang. Then you pull your eraser out, it's not a big deal. Everybody got it? Okay? This is one of the things I like about that little shortcut that I teach you. It always works. Remember what I taught you. Put your finger where your graph crosses the y-axis, okay? And then this guy tells you what kind of y's I want. I want the y's that are greater than. Would that be above my finger or below my finger? Above. So now your choice is, if I go above my finger, am I inside the parabola or outside the parabola? So that's what I shade. And that's my answer. Anybody got a question? Okay, so I'm going to show you really quick. I'm going to take this same problem, x squared plus 3x minus 4, and I'm going to complete the square on this guy. Should you know how to complete the square? Yes. People, come on. So let's see. We're going to go x squared plus 3x, close the parentheses, and then popula minus 4 out here. Are you with me? Okay, so what do I do now? Yeah, I'm going to half this guy. Since it's not pretty, I'm going to write it down so I don't have to think about it. Okay, so I'm going to say 3/2. Remember, if I had to factor something out, I would have drawn that rainbow. That cost some of y'all some time, okay, and stuff on your worksheet that you did because you would never draw that. And then whatever you did out here, you forgot to think about that number. All right? Now, what do I do with that 3/2? I square it. And what do I get?
9/4.
So I add 9/4 here.
And then so
You really added 9/4, and so whatever you do here, you have to undo here, because we're on the same side of the equal sign. There's a little y over here, okay? So, if I add 9/4 here, what do I do here? All right, so I'm going to write this as a quantity square, and it's going to be square root, keep the first sign, and square root of the last, or half of this middle number. They should be the same thing. Quantity squared. Over here, you got to have a common denominator. You with me? No, either way you work this problem, you got to work with some fractions. What's a common denominator between 1 and 4?
4.
So what do I do to this guy? Can you tell that your fraction skills have gotten better?
yes.
Good. We're going to keep on working on them. So -4 times 4 is -16. This guy's already over a 4, so I just write it down. If you're being dependent on a calculator to work your fractions skills are not better. Okay? In college, a lot of classes, especially a college algebra class, they're going to take your calculators away from you. Here's why. Because they want to know who knows the math and who's dependent on a calculator telling you the answer. Okay? So if you don't know the math, they're gonna cull you from that class. All right? They're gonna make you drop that class because you're gonna have a bad grade in it. All right? So learn your math. These are like signs, so I add and take the sign of both. Is my vertex the same as this vertex up here?
Yeah.
Yes. There's that -3/2. Change the sign and keep the sign. And -25/4. Okay? So, pretty cool. Are y'all okay? Does everybody know all that? All right. So here's your problem. It's particularly wonderful. Okay? Example 3. We're going to graph. Because I'm going to make it a system so that you get to do 2 problems in one. Y is less than or equal to -x squared plus 4. People, that graph right there ought to take you 1 minute to graph and shade. Y is greater than x squared minus 2x minus 3. And I made that guy nice. So, I'll give you a couple of minutes. y'all get this first guy graphed really fast?
No.
What does this negative do to my parabola? What does this plus 4 do to it? Moves it up 4. He does not move it left or right, people. Why? Because he is not in parentheses with an X. He is not an X. He's a Y. So all I had to do was take your standard parent function and say he's flipped down and he goes up 4. 1, 2, 3, 4. If you wanted to, could I do this? Could I factor that guy? Tell me what the first thing you would do if you were going to factor him.
Get the negative out.
Yeah, I would pull that negative out. When you pull the negative out, you get a positive x squared and a what? Negative 4. Now, is that guy easy to factor? What's x squared minus 4 factored into, guys?
Plus 2 is minus 2.
X plus 2, x minus 2. Another thing you could have done is you could have said negative x squared plus 4 equals 0. I'm just looking for my x-intercepts, guys, okay? And you could have added this x squared to both sides. And now what would I do? Square root. So x is equal to? What kind of 2? Plus or minus 2. You're going to get the same thing here. This guy, y'all, does this negative right here affect any of these roots?
Yeah.
No. What is the only thing that negative does? Tells me my parabola does what? Opens down. That's all. He has no effect on these factors. Okay? So this is a negative 2 and this is a positive 2. You could have done it like this. Or you, no, that'd be the best way. Okay? So, Katie.
What about in vertex form? Well, we have to add, and then we have to subtract
0.
on the other side, so would that subtraction become a positive?
It would just be a 0.
So that
Okay,
wouldn't
if you put
affect-
that guy in vertex form, look what he's gonna, do you agree this is what it's gonna be?
I'm just
That's
saying,
what you got.
if there's a number in there that would.
Okay, okay, but watch. So what is B? 0. So when you, it doesn't matter, you can do plus 0x or minus 0x. It doesn't make any difference. You still got 0. Subtracting 0 and adding 0 the same thing. What's half of 0?
0.
What's 0 squared?
0.
So, I don't know, you really subtracted 0, so maybe I'll add 0 over here.
So that's,
Okay,
so
so
it does change the
negative,
sign.
square root of the first, keep the sign, square root of the last, quantity squared. Left or right, opposite of what you think, up or down, just like you think. So doesn't move left or right any, goes up 4. Okay, so plus 2 and minus 2, is he solid or dotted?
Solid.
Very good. All right, I'm gonna put my finger right here. He's gonna tell me what kind of y's he wants. He wants the y's that are less than, would that be above my finger or below? Is below my finger inside the parabola or outside? Then I'm shading inside. Do you understand how if it had been greater than or equal to, that would have been above my finger and then I would have shaded on the outside? Y'all with me? Okay, so let's do the next one. Here's the next one, this guy right here. Y is greater than x squared minus 2x minus 3. Now, I see easy, I can complete this square really easy, right? You'll get to where you can complete the square pretty quick, all right? So, x squared minus 2x, separate that little negative 3 out. Are you with me? Okay, now what do? What's half of 2? 1 squared. I really added 1 because there's nothing out here, so what do I do out here? Alright, so then I have square root of the first, keep the sign, square root of the last, or half of this number. Y'all, square root of this number and half of this number should be the same. Okay? 1, quantity squared, negative 3 and negative 1. What's my vertex?
1, negative 1.
1, negative 4. So my vertex is 1, negative 1, 2, 3, 4. Okay, can I factor this guy really easy and find my x-intercepts? Yes, he factors really, really easy. So let's factor him. Okay, x squared factors into x and x. Plus and a minus, because the last sign's a minus. What are the factors of 3 that subtract to be 2? You can only do that when that's a 1 right there, guys, okay? And I want a -2, so I'm gonna put my 3 by the minus sign and my 1 by the positive. If x plus 3 is the, x plus 1, pardon me, if x plus 1 is the factor, what's the root? -1. If x minus 3 is the factor, what's the root? Okay, so at -1 and positive 1, 2, 3. That looks good, right? Solid or dotted? Dotted, very good. Okay, I'm gonna do that same thing with my finger where it crosses the y-axis. This is telling me, you can look up here, or you can look down here if you wrote it. I want the y's that are greater than. Okay, is that above my finger or below? Is that inside or outside? So now I'm shading inside this one. Now remember, on a system, what you had to do, you had to go and make the answer very evident, right? So this blue line is solid. This purple line is dotted. And it's all of this inside here. Okay, anybody got a question? All right, so that's graphing them. Can you do it? Can you do graphing them? Okay, so that shouldn't be that big a problem. I mean, you've graphed inequalities before, and you have, all right, shade it, graph and shade it. So this is example 5. It's gonna be the only one we're gonna get to, guys, okay? So, it doesn't really, the shortcut, I could work 3 of these in the time it's gonna take me to work 1, okay? So, but I'm gonna show you both ways, because I wanna hit whoever likes to do it. Okay, so this is what my problem looks like. 2x squared minus 9x minus 5 greater than or equal to 0. Okay? Now, what I'm going to do is I'm going to go over here and I'm going to write the rules for this shortcut, because that's really the one I'm going to use. I'll come back over here. I'm going to work it the long way first. I think it's the difficult way, but I'm going to show it to you. So, solve a quadratic inequality. Okay? So if this were an equal sign, we'd be home free. We'd try and factor that dude. If you couldn't factor it, how would you solve it? You could complete the square. I probably wouldn't, but you could always use what always works? Quadratic formula. You could always use the quadratic formula and solve it. Okay? So, here's what you're going to do. There's 3 steps, guys. That's it. 3 steps. The very first step is you're going to find what we call the critical values. Okay? Critical values. You'll see this word come up again this year. And y'all, the critical values are simply the zeros, the solutions. That's all it is. Okay? So, how do you find those solutions? What's the easiest way? Factor. Okay? Don't make me take that thing away from you.
You said the easiest way.
Factor. I can factor before you can pop that thing in a calculator. Come on, people. All right? If it doesn't factor, though, I can always use the quadratic formula. Stop saying calculator. I'm going to pull those calculators away from you. All right? So, quadratic formula. So, I'm either going to factor it. Obviously, I'm going to try and factor it first. People, if I can't factor that in 1 minute, I'm going to look at its discriminant. Will its discriminant tell me if it factors or not?
Yes.
Yes. If your discriminant is not a perfect square, it doesn't factor. Okay? So we would look at that. And then I would go, oh, well, I better put it in the quadratic formula. And guess what? You already have the discriminant, so you already have what goes underneath the radical. okay? Some of you, you're not good at factoring, so you might wanna get good at this, all right? But don't be dependent on this, because you need to know how to factor. All right, the second thing you're gonna do is you're gonna draw a parabola with those zeros. Which are your critical values. So really, all you have to know is, does my parabola open up or down? Okay? Once you find those critical values or those zeros, then you're gonna say, does my parabola open up or down? And you're gonna slap it on there. All right? The third thing you're gonna do is you're gonna have to make a decision. Do I want the hump, which is going to be between, okay? Or do I want the tails, which is gonna be on the outside? Now, that doesn't make any sense to you right now, but I'll show you what it means, because y'all, this is the coolest thing you've ever seen. It's a really neat shortcut. Very fast, I love it, I love it. Okay, so for all you little kids that don't like to do little shortcuts and you don't wanna do that, I'm gonna show you the other way to work the problem, okay? Either way you work the problem, you have to find the critical values. So, don't go, well, I'm gonna do it the other way because I don't have, no, you gotta find the critical values. So what I'm gonna do is I'm gonna try and factor this guy. Since he doesn't have that 1 right there, 2x squared factors into what? Yeah, 2x and 1x, or a 1x and 2x. And then I'm gonna get my pencil because I may be playing a game, okay? Probably not going to be. Do you see how fast, watch this. What's 2 times 5? 10. Do you think I can subtract and get a 9? Yeah. Because what are the factors of 5? 1 and 5. There's my 1. I'm going to subtract that 1 from that 10, and I'm going to get me my 9. You see it? Okay. So my signs are different. I want a negative 9. Usually what I do is I just write them in there, plus, minus, and I go, I don't care if they're wrong. I'll just erase them and fix them. It's not a big deal. Okay? So my only factors are 1 and 5. I'm trying to subtract to get a 9. Y'all, where does the 5 go? With who?
Negative.
Yeah, with the 2. I don't really care about the signs because I'm trying to make the number, okay? So, but he does go with the negative, and then my 1 goes here. I always check my inners are plus 1x, and my outers are negative 10x. And there is my negative 9x. And I accidentally got the right sign, okay? Because I just slapped mine in there. Some kids don't like to put them in there. They want to put them in there after, and they put them in the right place. Nothing wrong with that, okay? Nothing wrong with that. All right, so here we go. Let's see who knows what they're talking about. This is my factor. Tell me what the root is. This guy right here. 5. Okay? This guy right here is going to tell if you really know what you're talking about.
Negative 1/2.
Negative 1/2. Remember, you change the sign, and if this coefficient is not a 1, y'all, if he's a 1 and you divide by him, this number doesn't change. That's why we don't do it. But if it's anything other than a 1, you have to divide by that coefficient. If you still don't understand that, then this is what you need to do. 2x plus 1 equals 0. Subtract 1. 2x is negative 1. Divide by 2. There's my negative 1/2. Okay? Nothing wrong with this. After a while, you need to stop doing that, people, and just know. All right? Because this takes up too much time. All right, so here's my critical values. All right, so let's do it the difficult way. Okay, the difficult way. Now, on the difficult way, I'm going to write your directions down. Okay, I'm going to write your directions down. So, the first thing you're going to do is you're going to put the critical values on a number line. Y'all can do that, can't you? Okay? The second thing you're going to do is test numbers in each section. So your critical values are going to divide your number line up into sections. And you're going to test numbers in your sections. You're going to test them in this original problem. Okay? The third thing you're going to do is true statements are solutions. False statements are not. Okay, false statements are not solutions. All right, so you ready? So the first thing I'm going to do is draw what?
Number one.
Number line. Draw me a big old number line. Okay? I'm going to slap my critical values on there. Be sure and put them in the right order. If you don't, you'll be messed up. All right? Who goes to the left? -1/2 or 5? And then 5 goes over here. Are you with me? Okay? Now, how many sections did these two critical values divide my number line into? 3 sections. Left, middle, and right. Are you okay? All right. So I'm going to pick a number to the left. You can never pick critical value points. Okay? You have to pick in the sections. You can't pick the dividers. All right? So I'm going to pick a number to the left of -1/2. People, I don't care what number you pick. You can pick -953 if you want to. I'm going to pick the easiest one, which is -1. Okay? If you want to pick -7/8, go for it, people. Okay? I don't know why, because people are crazy. All right, so I'm picking -1. All right? Because -1 is to the left of -1/2. All right, and I'm going to plug him back in this equation, this inequality right here, and I'm going to see if he makes a true statement. If he makes a true statement, then any point to the left is going to be part of my solution. See? All right? So, here, I'm going right back up here. So I got 2 times -1 squared minus 9 times -1 minus 5. Must be greater than or equal to 0. Are you with me? Yes? What's -1 squared?
1.
What's 2 times 1?
2.
What's -9 times -1?
Plus 9.
Minus 5. What's 2 and 9? 11 minus 5 is 6 greater than or equal to 0.
Yes.
Then that means my solutions lie any point over here. Does it include this critical value?
Yes,
Why?
because it's or equal to.
Very good. It's or equal to right there. Good job. Okay? Now what are we going to do? We're going to do the same thing. We're going to pick a number in the middle. People, what's the easiest number to pick between -1? 0. I'm going to pick 0. If you want to pick 4.97562, pick it. All right. So I'm going to go 2 times 0 squared minus 9 times 0 minus 5 greater than or equal to 0. People, what's my answer? -5 greater than or equal to 0. True or false? False. No solutions. Every number that you pick in there will be a false statement. Okay? Let's pick a number to the right of 5. Which one to pick?
6.
That's what I do. My pen's running out of ink. So I'm going to go 2 times 6 squared minus 9 times 6 minus 5. It's supposed to be greater than or equal to 0. Are you with me? What's 6 squared?
36.
36. 36 times 2 is 72. What's -9 times 6? 54 minus 5. A -54 and a -5? -59. What is 72 minus 59?
13.
Yes. So 13 is greater than or equal to 0. True or false? True. So all the points over here make true statements. Does it include the 5?
Yes.
Yes.
Is that only if it's or equal to?
Yes. If this had not been or equal to, that's a very good question. This would have been an open dot. Okay? Now, here's what I want, people. I want to pick your brain. All right? I want to write this in proper set and interval notation.
forgot that.
Okay? That's what the other kids said. They were like, whoa, I forgot about that, Miss Davis. But y'all listen to me. We use this a lot in pre-cal, okay? So, proper set and interval. So here we go. Proper set, a brace, any x such that, what is this is? X has to be what? Less than or equal to -1/2. Or, I use the union symbol. You have to use the union symbol in interval notation, but instead you could write the word or, so I always use the union. Or x is what? Greater than or equal to 5. In interval notation, people, you are looking at it right there, okay? What does a left arrow mean? What's it pointing to? Negative infinity. Can you include infinities?
No.
Y'all, you can't include things that don't stop, okay? So always a parentheses is not included. So negative infinity all the way up to what? Negative 1/2. Is that included or excluded?
Included.
And what is that? Very good. Kevin, question?
It's like a negative 1/4.
Do what?
You said anything negative, but those negative numbers that are below negative 1/2.
That's okay. That's all the numbers that are less than negative 1/2. We'll make true statements in them.
Okay.
Okay? Union. Now what? None of this, guys. Now what?
Bracket.
Bracket 5. All the way to
Infinity.
positive infinity. Okay? All right. Now watch this. How much time do I have?
Like 5 minutes.
5 minutes. Watch me do the shortcut in less than 5 minutes. That took 15 minutes. Okay? So here's the shortcut.
Hold on.
Okay? Here's the shortcut. So the first thing the shortcut says, find the critical values. Boom, already did that. Negative 1/2 and 5. Okay? So draw a parabola with these zeros. All right, so what I want to do is I want to draw. You can call it a number line. Y'all, actually what it is, it's the x-axis. But we're going to kind of use it like a number line. Okay? My critical values are negative 1/2 and positive 5. Are you with me? The next question you have to ask yourself, how does my parabola open? Up or down? Everybody agree?
Yes.
A positive x squared. He opens up. Okay? He opens up. Now watch this. This is what I'm talking about. Are you listening to me? Okay. So now you're going to go back up here and you're going to read this statement. What does this right here represent? My what? My parabola. Doesn't that represent my parabola?
Yes.
So I want the parabola that is greater than or equal to 0. I want the parabola that is greater than 0. Y'all, this is 0. Greater than is where? Above or below? Above. So what is above? Is it the hump or the tails? So I want the tails. The tails is what? The outside. Y'all, where are the x's that give you these tails? They're out here. So there's my answer. Look, if that parabola opened down, and I wanted what was above or greater than 0, that would be the hump. Where are the x's that give you the hump? Yeah, the hump, this is the hump, and these are the tails. Okay? And they would be in between. Okay? Just the same thing, guys. Any x such that x is less than or equal to negative 1/2, greater than or equal to 5. Negative infinity to negative 1/2.